We have a microwave oven that was supposed to be stuck on all the time, even when you weren't setting it to cook. And it looks like it was running, at least the magnetron was running, because it looks like it got pretty warm in there. You could see it melted the contacts pretty bad on this safety device. This should cut out at a certain temperature, and it should cut out before the terminals melt like that. But anyway, I reconnected it all up. Somebody had removed a bunch of the wires, so I got the switches installed again and got it all connected. And I have a light bulb. You can see I removed the connections from the transformer that goes to the magnetron. This is the magnetron. This is the transformer that powers it. I disconnected the wires going to the transformer and connected them to a light bulb so that we could, if the light bulb comes on, that means that the magnetron would be on. So, as you can see, the microwave is plugged in right now, and it's not trying to run. And you can see the light comes on the inside, and everything looks fine. And if we add, say, 30 seconds, I'm going to press that button, you'll see the light come on. So you can see that light coming on. So if those wires were connected to the transformer, it would be getting hot in there. Whatever we put in there would be cooking. So let's see if it shuts off. And it shut off just like it should. I imagine the main cook relay in there is probably bad, and when the transformer is connected, it draws enough current that actually welds the contacts together and keeps it on. So I'll probably take that apart just for fun. This microwave is missing the glass tray that should go in there along with the little roller ring. So without that, this microwave isn't good for much, except maybe scientific experiments in the garage or something. So anyway, we'll take that board off here and see if we can see those contacts on the relay that are burnt. So I have the microwave board out, and this is the relay right here that we need to take out and look at. That's the one that controls that transformer that we were looking at earlier. So powers that. Let me turn this slide around here so you can see a little better there. So we have to remove two solder joints right there and right there. We have to desolder those. And I have over here, right there, a little desoldering station that it's a soldering iron with a vacuum connection on it. You can see the little hole there. And when you press the button, it vacuums up the solder. So that is what we're going to use to remove the solder from that relay. So I'm probably going to be in the way here. So I don't know if you'll be able to see very well. Figure out where that guy is. I think it's rolling right there. We'll put it on the solder joint, wiggle it around a little, vacuum it up, do the next one, wiggle it around a little, vacuum it up, and then, as you can see, well, hopefully, I don't think we quite got it all out there. Oh. Is there another one? There might be another one. How about that one right there too? That was it. There was 3 of them. So now we'll set the desoldering station down. And I'm going to go ahead and power it off so we're not wasting electricity there. I don't think we'll need it. Alright, so now we can take this relay. Try and get you in here closer, you can see. Let's see if we can get this relay open now. I think I'm going to drop you down closer here. I think I can drop you down closer. Or there's something in the way there. Okay, we're back. I hope this is gonna be good enough for you to see there. So I'm going to get a screwdriver here. If I can find one on my messy bench. Oh, there it is. And we're going to attempt to, well, that wasn't too hard. So I'm just going to kind of cut back the glue there on that relay. So hopefully we can get the cover off and see what we got inside. Let's see here. Yep, looks like it's coming. Let's see if we can push those leads out from the other side. Might end up breaking this, not sure. Let's see if we can push those leads in. There's some glue on the leads on the bottom side there. Pretty sure this guy is bad, but we'll go ahead and try to save it. Try not to destroy it. Always try not to destroy things. Unless we're doing that for fun. Ooh, what a mess. And just as I suspected, as you can see, those contacts are burnt. The same thing we saw in the oven control panel. And what happened was, same thing that happened with the oven control panel, is when this relay engaged to turn on the magnetron tube in the microwave, there was enough current in these contacts, say, 10 amps or so, whatever a 1000 watt microwave would do. A 1000 watt microwave, say at 120 volts, is somewhere in the neighborhood of 10 amps maybe, or whatever. Now this is a 16 amp relay, but over time. And as you can see, what happens is when that magnetron kicks on, this makes contact, and if these contacts get burned over time, they'll actually weld themselves together, and then the magnetron will stay on all the time until the thermal cuts out, or it burns a fuse. And as you can see, I don't know if the thermal cutout actually cut out. It may have, but then as soon as that cools off, the microwave, the magnetron would come back on and start heating again, unless these contacts cooled enough and were able to separate. So this particular microwave would need a new relay. Nobody would take the time usually to repair these. You would just order a new board off of the internet somewhere. Some of these boards can be quite pricey, and if you have the skills, going and getting a $5 relay is a lot cheaper than maybe a $40, $50, or in the case of that oven that we repaired the other day, that board could be $200 or $300. So anyway, that's the problem with this one. I'm not going to fix it because that microwave is missing parts, but this might be a good board for another microwave project in the future if I get one of those relays.